know how you can do it with some simple tools. First, let me just get rid of this stuff. I will just import geometry directly from Maya, which I did last class, right, with IGES. Remember that? This is a file format. You can create connection between Maya and Rhino. So the form came in as kind of rotate 90 degrees because Maya is a Y up, Rhino is a Z up. The first thing I want to show you is there's a command named rebuild. Maybe I should turn off the light. That looks better. Better? All right. So the first command name is rebuild. So you can pick up the surface, enter. So you can rebuild the surface. First question is, we all understand the U and the V, right? This is basically how many subdivisions you want to reconstruct this surface. So right now it's a 10 by 10. We all know that. So what does the degree means? In Maya, if you remember, when you create a geometry, for example, if I create a surface with a sphere, here you can see by default the degree is cubic. That is actually 3. Cubic is 3. It's actually using 3 point to simulate the curvatures. So it's always come from can generate a really smooth geometry. If I switch the degree from cubic to linear, which is 1, you can see how this sphere looks like, right? It's became a rigid form. And also I can easily increase the number of sections. And then you can see it's still as a rigid. So here then in Rhino is exactly the same. If I build these geometries with degree U, I will keep as 3, V as 1. If I click OK, see the form looks like. It's smooth along these rings, but it's a straight line along the height. See that? Right? Let me redo it. So this time, if I will just build as 5 by 5. I think this will be easier to see. You got it? Right? So it's smooth along this profile, but straightforward along the height. If I rebuild this one more time, and this time I change U to 1, V to 3, click OK, see what happened? So it's smooth in another orientation, but straightforward along the profile, along the rings. That makes sense? So this is very important for you to understand the rules of NURB surface. It has U and V, has degrees along U and V. They are independent, so you can switch between these two. One thing I want to mention is if you want to do a unroll command directly to this surface, it's not going to work because, see, this is how Rhino works. If you have a simple geometry like a box, if you do an unroll surface, you can pick up this geometry. You don't want to explode the surface, right? This option will be no. Click enter. It basically create the surface like that. Okay? So it's flat, this cube, the box, into a sheet. Later you can folding back. So I probably need, go back here. I want to make 2D, right? This is how Rhino works, make 2D. You pick up this geometry, make sure you check show tangent, current view. Okay, so get this shape, you can do the laser cut. Very straightforward. You probably want to do a join, G-O-I-N. So they are single geometry now. Oops, probably want to do this one more time, join. Okay, so this is how it works. However, if I make unroll to this guy, Let's see what happens. It's not going to work. The reason is all of these curves are too complex. They are in 3-dimension world, right? It's not like a 2-dimension surface. So in order to make this work, you have to use this command. The name is extract wireframe. You can actually see this option right here, extract wireframe. So hit enter. As a result, if I drag it, you see that is original curve, original surface, and extract wireframe will generate all the curves directly from that surface. So this is really cool. I don't need this direction, so I delete all the curves. So this is basically all the profile, right? You can get from Rhino. So the next thing I'm going to do is I select this 2 curve. I will do a loft, L-O-F-T, enter twice, click OK. So you generate that surface is right here. If I do this with this 2 curve, loft again, I can generate another surface. All right, so if I keep doing that, eventually I can rebuild the whole skyscraper, right, using this way. And you might notice the difference of this approach is there's no continuities across these 2 surfaces, right? Also, the line is straightforward. So you can tell the degree along this orientation is 1, right? It's a straight line. Only in this fashion you can unroll. So let's do unroll surface. I can pick up this guy, enter, see what happened. You got this nice. All right.
In the beginning, there was nothing. Only an idea.
Do you know where the sound comes from?
But I believe that you could build anything out of almost nothing. You just have to strive for perfection. In 1949, I founded a sports shoe company, Onitsuka Tiger.
I don't think that's from me.
My name is Kihachiro Onitsuka. It all began very small. In Kobe, Japan. My foster dad lent me a desk
That's not from me.
so I could get started. One day I was at my mother's house eating a Japanese salad. Suddenly I found a slice of octopus stuck to the bottom of the bowl. It wouldn't come off. The thought struck me. Why not use this technology to have a better grip on the ground? The result was the first basketball shoe in history for suction cups in 1951. And I am proud of what has come out of my small shoe company, employing 4,000 people across the globe, selling over 30 million pairs of shoes annually. No matter which sport.
Very sorry for that. Oh boy. Okay, I know why. Yeah. You never want to run 2 computers at the same time. Sorry for that. I think now it's safe, right? Okay, see if I can switch back. I hope so. Okay, laptop selected. I think I should deactivate first. And then make it back. That is a big surprise. All right. So what we are now? Yeah, let's keep talk about unroll. Okay. So we know. Okay. So we know the trick is you want to make sure you pick up only 2 lines and then do the loft. So the curve you generate is only 1 degree curve. In this case, you can do unroll surface. Enter. So you can see that surface will be generated right here. And after that, you can go to the top view, right? Then you can use make 2D. To generate the profile based on that ribbon. So this profile, if you laser cut, and later you folding this edge to this edge, it guarantee you can recreate this curve. Right, so that is the whole process. If you want to build a skin layer by layer, or level by level. One thing you want to see the difference is if you loft all the curve together, not 2 by 2, if you loft everything together, this is not going to work because you can tell between these lines, this line, right, between these profiles, this line is not 1 degree straight, right? It's a curved shape. That makes sense? Actually, in the real construction of a skyscraper, you can think about this as a glazing system. And the glazing system is always made up by many, many panels, right? The panel is always flat. It's a 1 degree surface. It will be extremely expensive if you want to do a curve, 3-dimension curved panel. Maybe you can see that in aircraft or car, but nobody really do that in a building. It's super expensive. That makes sense? All right, so this is one options if any of the team want to do the skin. But as I mentioned before, this is optional. I don't really require you to do the skin. I think only the massing, the floor plan will be complex enough. All right. Another way you can do the skin, I will show you a program. I'm not going to do demonstration today because you can pretty much get all the information you need from this website. If you Google the name, this one is a Papakura designer. Papakura, right? That's the name of this. You can basically unfold a really, really complex geometry into a 2D patterns. Right? So for example, a dinosaur. So you can definitely do that, and later you can fold in. In this case, you probably want to export your Maya model directly into this polygon mesh, and this program will automatically break apart. So I can show you some examples, like actually in my website. It's using this program. Let's see. Actually not here. This one. Oh yeah, this is the one. Okay, so you can see this is the skin of the skyscraper. With the Papakura program, you can kind of break apart this into paper, and then you can fold this back into a building. All right. So this is a program you can definitely help you. I will show you some projects made by my students a long time ago. So that is a shape come from that Papakura program. So basically, the process is number one, you do all the 2D cut like that way, and then you carefully glue these edges piece to piece, so you can reconstruct entire tower like that way. If the shape, for example, if it is a sphere, you can get these patterns like this way, and then you can fold it back. So that's a 3-dimension sphere. You can paint color later. Let's see. So here's another example. This is how the paper can be folding back. All right, so I will keep this optional. If you do have some extra time, maybe close to the final project, if any of you in the team want to do the building skin, this is a program you can play with. All right, so I don't cover in the class. If you have some interest, we can spend some time in the studio to work on that. All right, I think that concludes the talk about the building skin. So two ways: either in Rhino you do the unroll, or use that Popokura program to do the paper origami stuff. Okay, so let's talk about something new today. It's about Maya rendering. I think last Monday I covered really brief about the mental ray rendering. So today I do want to show you some alternative way to do renderings. Is use Maya standard software rendering, which is in the render options, Maya software. The reason is sometimes if you do mental ray rendering, it requires a lot of computation. If your geometry gets really complex, it's super slow. Also, sometimes it might crash your computer. Maya software rendering is very safe. It's quicker than mental ray. And the effects is actually not bad at all if you know how to set up the lighting. Okay? So today I will demonstrate really quick how to use Maya software for rendering. I will do exactly the same as last class. I will just create a really simple thing, use a couple of spheres. All right, put it there. Okay, I think that's good enough. Lower a little bit. Okay, so I'm going to set up some lighting for Maya software rendering. So first, I'm going to create a light. This is all the available lights in Maya. You can find more tutorial in lynda.com. So now I just create really simple light. I will do a direction light. This is more like a sunlight. It has only one direction. After you create the light, sometimes you see, well, where is the light? So the light is actually hide in another place. So we want to just move this back, delete this guy. All right, so you see this direction light. I'm going to make it bigger. I will rotate. Okay, so this is the light. Control A. I can open the attribute panel of this light. Right, Control A is the attribute. So in the shadows, by default, the shadow is off. So I can easily turn on the shadow. I'm going to check retrace. Retrace is a more accurate way to calculate the shadow. After you check out the retrace shadow, just make sure in render settings, Maya software rendering, you do want to check out this option. I think the name is retrace quality. Make sure you're active. Because default, to save some rendering time, Maya will turn off this retrace option. Because it could be pretty slow in terms of rendering with retrace. So I reactivate the retrace and then do a rendering. Just hit render. That's it. You got this rendering immediately. That's pretty quick. So that's my first light. Then I'm going to build up the second light. So lights, I'm going to create a point light. Usually I will make the point light a little bit far away. I will give this point light some blue color. Control D, I will duplicate this light. I will make the second light a little bit lower, make the color as a little bit yellow, or maybe purple. Okay. Intensity of the light, let's give 0.5, so it's not that strong. Okay. For the direction light, the same thing. I will give the color to orange. Okay. So now let's do a rendering, see what's the effects. Okay, so you got a mixed color from that lights. Okay. So this is the Maya software rendering. You see the effects is actually not bad, right? It's pretty quick. You can also set up resolution exactly the same as Mental Ray. So here I can increase the resolution. Let's give 1200 by 800. In the Maya software tag, here I can check the quality to production quality. So this will take a longer time, but it's more accurate. All right, so now let's do the rendering. You see it's taking a longer time, right? I use the Maya software rendering if Mental Ray crash. If you have really complex geometry, you have to use software rendering. It's quicker. So you got these outer spheres. For the background color, let's go to perspective camera. You can use Control A to open the camera's attribute. So here you can see it has an environment tag. The default background color is black. I will give this to blue. Okay, so that is in the perspective camera's attribute panel. Now let me render again. It should give me a blue color. All right, but I want to show you is actually this blue color is not that important. The reason is in the computer graphic there is a concept. The name is alpha channel. So if I click this black and white, you can see alpha channel is actually will define the edge or the boundary of your geometry. If I save this rendering, so I go to File and Save Image. If I save this image as a Maya, as a TIFF, as I mentioned before, this is an uncompressed version, right? TIFF. Let's give this name rendering. So that TIFF file will actually remember the boundary or the edge of your geometry. So if I open Photoshop and load this TIFF file, let's see what happened. You can actually get a transparent background very easily. All right, so this is in Photoshop. Then I'm going to open that guy. The name is rendering. Okay, so this is the image looks like. If I go to select load selection in Photoshop, I can see there's alpha channel here. Click OK. You can see the selection immediately. All right. So the benefit is if you know how to use layer in Photoshop, you can use Ctrl X to cut, Ctrl V to paste. Right. So basically, you can remove the background. Then you can use Photoshop to load another background layer underneath the current layer. That makes sense? So this is the quick way if you want to do the environment. You don't have to build 3D model. Just rendering as alpha channel. Then later you can load into selection. That makes sense? All right. I will show you one more thing about Maya rendering. Besides software rendering, there's another rendering type is Maya vector rendering. Okay. Again, if you don't see this option show up, you have to go to the plugin manager. Just make sure you active vector render plugin. Okay, this is the plugin should be checked. So what does this mean, vector rendering? Well, if you switch to Maya vector rendering, you can basically save the file into Illustrator AI file. So that is a wireframe, is a vector format. Is everybody understand the difference between vector and pixel or bitmap? Okay, vector format is like AutoCAD or Illustrator, is based on the equations, mathematics. The pixel image is based on individual pixels, so they are quite different in terms of the algorithm. So here I can save the file as AI file. In the Maya vector tag, I will make a decision. Well, I don't want to fill colors. However, I want to render edges. Let's make a thick line. I want to render all the mesh. I want to render color as red. So that's pretty much the options you want to choose. And then I can do a rendering. You see, by default, this AI file will be saved into this path. Right? You want to read the path. So right now, the C drive TM project 2 images. All right, so that's the location. Then I can do the render. Just click render. All right, the rendering is done. Then I can take a look at that location. I should see a Illustrator file right there. So my project 2 images. Right, so this is the Illustrator file directly from Maya. Usually I use this technique to get a wireframe. Sometimes you do need something more architectural, like section views, plan views. You can render a Maya file directly into Illustrator. It's pretty clean. So let's take a look at that file. I think I have maybe too many programs open at the same time. So here we go. All right. You see, this is a wireframe. Pretty cool. And then you can do a lot of things here. I'm not sure how familiar you are with Illustrator. You can change colors. You can change the line weight, right? You can deform the geometries. There are many things you can do here. Okay. Any questions about Maya rendering? So let's repeat one more time. We have Maya software, vector, and mental array. Maya hardware rendering is only for particles. You don't have to know this. In the future, if you do want to render some special effects like smoke, fire, or particles like snow, you can do Maya hardware. It's pretty good to handle these particles. All right, so that's pretty much about rendering. There's another thing I do want to highlight really quick. Is for this midterm project. I know some of your team want to do a kind of really complex shape, which later you might find is very difficult to assemble them together physically. What I mean is, if your shape is really, let's see, kind of strange shape, let me just let me redo another one. I want to keep as a linear. So for example, this is a shape of your skyscraper. Okay. So surface, I'm going to close a curve. And you want to animate individual points. Let's see, 300 frames. Let's give All right, so this is 300 frames. And you want to animate this, let's see, in the first keyframe, this is all the points. You can use S. At the end, maybe you want to move these points, make it really far away, or maybe rotate. You can do this with cluster, which maybe is easier to control. So you can see the animations. You can animate every single point in this building, but keep in mind, you do want something in common, so later you can assemble them. In this case, no matter how the building profile change, I probably will keep this center always here. I mean here. So this part will be my elevator. Maybe it's better to do this as a square shape. Easier to understand. Okay. So in the future, when you assemble this in Rhino, this point in the middle will be the elevator. You can stack all the pieces together. Okay? However, if all the points are moved really far away, I mean in the middle, if you move the entire model here, this will be a problem because, let's see, at the beginning is here, at the end is here. Right? If the shape is kind of flying like that way, there's no common point. You can snap them together. Does that make sense? Right, so if you do want to do some really crazy shape, just make sure there some point of these layers, these levels, is never changed. Right? So you can pin down all the layers based on that point. Okay, think about it as an elevator. Okay, so that is some trick I want to just highlight for your midterm project. All right, we still have a little bit of time left. Is there any particular questions for the midterm? I can use this time to kind of troubleshoot. I'll give you some tricks. Questions about midterm project? Yeah, go ahead.
Say you take a shape and you have the animation of all the outline.
Mm-hmm.
How do you take those individual lines and lock them into the third slide instead of the entire skin thing?
So you want to loft every two?
Yeah.
You want to loft every two lines? Like in Rhino?
Space in between.
Like in Rhino? Is this the one you want to loft? Or you just want to simply extrude?
Extrude.
Okay, I will show you. First, let me just break the connection. Break connections. Yeah, her question is how we can just make a stack, right, of forms, like a cake, layered cake. Is that right? Okay. So this is the animation, right? Right now is not move along the Z. So first thing I'm going to do is, for this curve, I can easily, there are a couple of ways you can do it. Let me think what is the easiest way. Probably I will just do a planar here. So planar will basically use a curve. Let me move this planar a little bit. So it's basically using that curve to drive the surface, right? So this is planar means, is right here, surface planar, okay? After I generate the planar, and then I'm going to convert that planar into a polygon. So I will use, let's see, probably just control points. Oh, not control points. I will do a count. Let's give 500. That's too much. I think 100 should be good. All right, so this is the polygon version. If I play, you can see they all works, right? So this is the original line. This is the planar surface. This is the polygon, right? I can see this is a polygon face. Then the next thing I'm going to do is extrude that polygon in 3D. right? So extrude. Just make sure coordination is up. So now if I play, right, you got everything follow the original one. This is the beauty about parametric design. Then I'm going to do is animate this guy. You can either animate this one, or I can animate this final one. I mean, it's pretty much the same. I probably would just animate the final one. So S, and then we'll move up. Use S, and I will do animation snapshot. Use timeline 100. So here we go. You got this sequence. If I look at from top view, that's the form looks like. Okay. So let's move this a little bit. Right, so you can see this is all the geometry generate. You have the animation, you have the stacks. This the thing you want to do?
Yeah, is there a way to measure, like, since we're making these out of materials later, like, is there a way to measure the actual dimension?
Yes. There's a tool in Maya, the name is a dimension measure. See, if I want to know how big this geometry is, I can go to create, measure tools, distance, and then I can pick up 2 points. You give me a number here. All right, 46. So it's right here, create, measure, distance. Okay, any other questions? Yeah, I think this is good. You know, the ask question is the best way to learn. I would say so far probably we covered like 10% of Maya command, maybe less than 10%. So it's always good, you know, if you have some idea, just ask me, then I can show you some way to do it. Also, after today's class, there's some reading work to you.